Okay, so let's start with the usual reminders. And for your programming test number 1, it's going to be next Friday. And I already released the Lab 1 solution today. You can take a look and let me know if you got any issue. But the tutorial video I made for Lab 1 solution is very thorough. You can also, there are timestamps on the YouTube video. You can also go to the parts that you feel necessary for you to study. Otherwise, you can just develop with me, pretty much like a Lab 0 style. But the resources is there, so you can take a look. And your next Friday will be your programming test 1. For this Friday, June 6th, it will be the normal optional attendance. TAs will be there. Myself will be there. We'll just help you with lab number 2. Or if you got any questions related to lab number 1, you can also come by. Okay. And I'm just going to release the guide very soon about the programming test 1 coverage. And also there will be a survey on the review session, which will happen next Wednesday, most likely. Not this coming Wednesday, but next Wednesday. And we are still grading your programming test 0. I'll keep you posted. I'm hoping by the end of Friday, if no, Monday for sure. Okay. And your priority, you should really take a look at Lab 1 solution. Make sure you grab all the learning outcomes. You know how to do things from scratch on your own. And lab number 2 is also quite important. Lab number 2 also requires quite a bit of struggling to really see how things work together. And also lab number 2 also require the understanding about exceptions, which we basically have covered all the basic and also principles so far. But today, I'm just going to do a little bit more example just to review quickly the ideas about catch with specify and also caller callee, things like that. So these are fundamental for your understanding. All right, any question about the course? All right, let's now do a recap from last Thursday. So last Thursday, we basically continue with that to handle or not to handle example, and then also try to do version 2 and version 3. You can definitely study the differences between the different versions. But we talk about the catch or specify requirements, right? So for the catch option, you just got try and catch block, and we'll see more example today. Especially, we're going to see how the execution flow is going to work when you got exception either happening or not happening, either way. And you also got the specify option, which will require for your method here, which might throw some exception. You'll simply say throws a single exception. If you got multiple exceptions that might be thrown, you might just say comma and then another exception, which we also spoke about last time. Right? You got catch or specify. And we spoke about the execution flow. You can look at the 2 different scenarios. Scenario where we got the try and catch block. And also for try and catch block, either the exception did not occur or it actually occurred, right? So these are the 2 scenarios. You want to see how the execution flow is going to differ. And we're going to see more example today somehow. And scenario number 2, let's say there's no try and catch block, in which case we're talking about the caller simply specifies the exception. In which case, this method call here may or may not actually throw the exception. You also want to see how the execution flow might differ, right? Depending on whether it's actually thrown, the exception. Right? We also try to visualize the caller callee using call stack, right? And I think this one here will just review version 1. Like version 1, version 2, version 3, right? They are of different flavor. So all of them are valid solution. But which one should be taken kind of depends on what you need for your application, right? So you want to think about throughout your call stack, at which point you want to do the try and catch block. You got to decide somehow. It's more like a design choice. But for your lab number 2, the JUnit test cases themselves actually specify about where you should really throw or catch the exception. You will see that from the JUnit test cases. So really start your lab number 2 early so you get a feel about how programming test number 2 later is going to be about, right? Just start early. Reach out to me or the TA if you got any questions. All right, version 1, version 2, and also version 3, right? So these are the 3 versions. And the source code is also on the lecture side. Please take a look and play with it with your own creativity, really. Just play with the code. All right, so this page here is very, very important. It's like a generalization about the catch or specify requirements. Very quickly. So let's say we got a call stack, visualizing a chain of method call. We got method call number 1 all the way down to method call n. So this is where the execution starts from. We'll call it the entry point of execution. We start from here, and we stack up all the way to this. This is the method where some exception might be thrown. That's the origin of the exception. We say that typically in this origin method here, we only do the specify option. We don't really do catch right away. So that means at some point, this is going to specify or propagate the exception to its caller, and this caller may also propagate the exception to its caller as well, and etc. So to really analyze this kind of general scenario more carefully, we say that we assume, let's say this is the method where we first try to handle or try to catch the exception. Let's say this is the first point. That means all the previous callees over here, they choose to specify. You basically specify all the way to the very first method that you want to catch. So once you catch up to here, that means the catch or specify requirements are only imposed for these methods. All the methods down here, they are not subject to the catch or specify requirements anymore. So that's the most important message for you to remember. Okay? So look at this general scenario over here. Try to see if you can somehow modify the to handle or not to handle project over there, and try to see if you can make the scenario a little bit more complicated and still test this kind of visualization, right? That'll be my recommendation for you. There are certain experiments which we cannot really do during the lecture. You should really do that by yourself, right? Just try to reach out a little bit, explore yourself a little bit further. Any question about this page specifically? Yeah.
My question is, I remember the last class you asked a question about how many specifiers. How do you count?
Okay. Yeah, so here, how many methods will specify? Okay, first of all, how many methods are subject to the catch or specify requirements? Let's answer this question first. Given that this is the very first method that's going to catch, so that one should be counted. So that will be I here, and then all the previous one from 1 all the way down to I minus 1, right? You can see the pattern here. Because before mi, it should really call n I minus 1, right? So this method here is going to specify, this method here is going to catch, it's going to handle. And then all the previous ones are going to specify. So we got I minus 1, they are going to specify. We got exactly 1, that's going to catch. Overall, we got I methods that will be subject to the catch or specify requirements. And the methods over here will be n minus I that will not be subject to the requirements anymore, right? That's kind of precision we want to aim for. I'm glad you asked, but it's good to just review it again. Okay. All right, guys, I think this stack here really gives you the precision about exactly how many methods will be subject to the requirements, how many of them will be specifying, how many of them will be handling, and also how many methods will be not subject to the catch or specify requirements, right? You want to get that precision right. All right, and then we started with this example here about circle. So we talk about circle class and then set radius, which will throw some exception if the input radius is actually negative, right? Less than 0. Okay. And the last page that we spoke about is about some extension to the actual console application. I want to start with tracing that particular application together with you so you can see a little bit more about execution flow. All right, let's take a look. All right, so that's version 2. Okay, so we still have our invalid radius exception here, right? And we got our circle class, right? Let me just show you very quickly, right? So if you think about the caller, would be circle calculator 2, and also the main method. This is where the method is being called. And then we got this method here, circle, and then we try to call the set radius method. So that's a callee, which may or may not throw that invalid, which may or may not throw that invalid radius exception, which is right here, right? So we got circle and also set radius, right? And this method here has no further method call. So there's only one caller-callee relation that we are analyzing, right? And of course, I'm going to leave the detailed study of this code here to you. You got to really see how exactly this Boolean attributes is, not attribute, how this Boolean variable, local variable, is being used to really control the entrance and exit from the loop. But let's just help you a little bit by tracing the code together. It's more like a console application, right? You will see this also part of the example code I made available to you on the lecture site. The user is going to interact with the console. First of all, they're going to enter -5. Somehow -5 is going to trigger this exception. But we don't really throw that exception directly to the console. Instead, we try to let the user enter again. And when they got a second chance, let's say they enter 10, which is actually valid. In this case, we're going to return back to them on the console the calculation result. Right? So these are the two interactions we want to trace for you. All right? At the same time, let me also put right here. Let's say this part over here is the console that we're going to trace at the same time. Okay? So this is the console right here. And we're going to see exactly the execution flow. We're going to start from label 1 all the way to some other, maybe label 22, whatever. Right? Let's see exactly. What we're going to do is we're going to assume the following pattern. The user, first of all, is going to enter -5 and then 10. And I want you to also look at this particular Boolean variable here, right? So that Boolean variable here, I'm going to put it here. Okay? It's more like a primitive variable. Input radius is valid. Okay? Input radius is valid. In the beginning, it's simply just false. Right? I'm making that very explicit right here. Right, let's now trace the code. In the beginning, we're going to assume that the user ultimately is going to enter -5. So we start with the main method here. So that'll be the entry point of execution right here. Okay, so we're going to say 1 here, and then 2 here. 2 there is going to initialize this variable to be false. And then we're going to go for number 3 here. Number 3, we are going to check to see whether we should go into the while loop for the very first time. That way there, you can see there's an exclamation mark here. Not false. It's going to be true. So we go into the loop for the first iteration. Good. And then we're going to go for number 4. We're going to print out something to the console. Enter a radius. Enter a radius. And then we're going to, actually number 5, we're going to set the R to be something that the user is going to enter. We assume it's going to be -5. Okay? So think about R right now is going to be -5. It's set to be -5. So that'll be number 6. And then number 7, we're going to go for the try block over here. Let's say number 7 is just about entering the try block. And then number 8 is going to be the first line, which would be, we want to set the radius, number 8 right here. Okay, we want to set the radius. And we are now somehow, imagine that in the call stack, right here, in the call stack right here, so we used to be doing circle calculator number 2 dot main. And then now we are doing a circle dot set radius, right? By making this call right here, set radius. Okay. So number 8. So where will be number 9? We're going to switch the context like a step into. So you can see set radius is right here. So I'm going to execute this method here for the first time. So number 9 is going to be the if condition over here. We're going to check to see whether R is less than 0. R over here is set to be -5, right? So that means the R over here is -5. So this one here will be -5. -5 less than 0, true. So we're going to throw that exception. So this will be number 10. So I'm going to throw this exception. At the same time, the else part is going to be bypassed explicitly. All right? So I'm going to throw the exception here, number 10. What about number 11? You can think about as soon as we execute number 10, we're actually going to remove this method from the call stack. So we got to go back to the main method here to resume the execution. We used to be suspended right from this point. So now we want to continue. We got 2 choices. Either we continue to here or we continue to the catch. Which one? Catch. because we got exception thrown. All right? So what we do is we're going to go for the catch. So that's going to be number 11. Number 11 over here. So that means the rest of the try block is simply bypassed. 11 is going to catch that exception, and then number 12 is going to print out try again. So that's why, oh, by the way, enter radius, the user is going to say -5, right? And then we're going to see try again to the console. All right, so far so good? Okay. At this point, you can see that this variable here, Boolean variable, remains to be false. That means the next time we evaluate this condition here for the while loop, it will still be not false, which will be true. So we still have to keep prompting the user until they enter something that's valid. We'll see how this is going to happen. So after printing this, we are basically going to reach the end of the catch block, right? So we're going to go to the end of the catch block, and then we're going to go back to this while loop right here, right? We're going to check it. Yeah?
Just to clarify, the -5 over there is the one which you are showing over there is the one which user input, right? It's not the fixed.
Sorry, say it again. I don't quite catch you. Can you say it again?
The -5
Yeah.
is the one which user input, right?
That's correct.
So that's why you are displaying on the test.
That's correct. So let me just clarify this very quickly, because there are two inputs the user will type from the keyboard. So this -5 here is exactly typed right here. So that's why the -5 will be stored into R. And then we're making the method call set radius with -5 for the first time. Okay? So now after we print this, we have reached the end of the catch block. So now we got to go back to the while loop. All right? So now if we go back to the while loop, this will be 13. And this will be a new interaction. So for the new interaction, I'm just going to say 10. 10, well, let's assume next time the user get prompted again, they're going to enter 10. So this will be, I would say, number 13. And, oh, beg your pardon, I put it in the wrong place. I really meant to put right here, right beside 3. So 13 over here tells me that I'm going to recheck this Boolean condition here. Not the case, input is valid. So not false will be true. So we still go into this while loop for a second time. All right? And then we're going to go for 14 over here, which is going to print out enter a radius. And then after that, we're going to read something from the user. Let's say this time we assume the user is going to enter 10, right? If they simply type 10 to the console, and then, so this is going to be 10. So R is going to be changed to 10 right here. So this will be 15, this will be 16, and then we create a circle objects, and we still go to the try block, right? So 17 will be, we reach the try block, 17. And then we try to call the set radius. So this will be 18. Okay, call the set radius with the value 10, right? You can see the 10 is the current value, 10. So now we again try to execute, step into the set radius. So that will be 18, so we get 19 right here. So we execute this method here for the second time, right? Set radius. So this will be 19. Okay, I'll try to write maybe a little bit better. So think about this is 19 right here. So right now we got 10 as the R value. So this will be 10 and this will be 10. 10 less than 0, false. So we bypass the throw here. Instead, we're going to execute else, which will be 20. Else part. Okay. That one there is going to set the radius to be R, which is 10. Okay, so far so good. So after this, you can imagine that we're going to remove this method call from here. We're going to resume in a similar way. So now we are finishing executing this method call here. We got two choices. Either we go to here, or we go to the catch block. Since this time, no exception has occurred. We just perceive as normal. Okay, that's very important. So this will be 21. Okay, sorry. So this will be 21. 21 right here. At the same time, the catch block is bypassed. Okay? So the green one there is normal flow, so we bypass the catch block. So 21 is actually going to set this Boolean flag to be true, no longer false. So it is true right here. And then we go to 22, which is going to say 22, 23. I can execute them at one go, just to show to you. It's going to print out something like this. It's going to say, I'm running out of space, I'll put it right beside that. Circle with radius 10 has area, something like that, because it's called the get area method, right? So the get area method is actually going to use just the radius r, 10 value, right? That detail you can definitely trace by yourself. All right, so now we are at 23 here. So now we are done with the try block. So what we got to do is we got to make sure we actually exit from the loop. But how do we do that? So 24 is going to be, we try to go back to the beginning of the while loop right here. Again, after we reach the end of the try block, we got to go back to the while loop to see if we need another iteration. It turns out we don't, because if you reevaluate this condition here, not the case, this is now true. Not true will be false. So exit from there. All right? And then after that, we're done. So this is the place where we exit from the loop. So that's the complete tracing and also the output you can expect to see from the console. And as I said, the source code is already made available to you. You should really play with it, maybe with different inputs, maybe more interaction with the user. So the critical points you really want to pay attention to is about how we use this Boolean variable over here to make sure we just be tolerant about the users entering negative value like -5, -6, etc. until they enter the very first non-negative value for us. So we can take it and calculate the area and finish the program. All right? So that's the main lesson you want to learn from this example here. Right, guys? Any questions? Should we visit the which method? You mean the get area? Yes, we definitely should. You can think about it as part of this. Somehow I just didn't include it in my tracing. You should. Because you can see when we did here, when we did 23 over here, as part of it, we actually somehow have to call c.get area, yes. If you want to do further tracing, you can feel free to say, maybe after 23 here, maybe 24 will be about get area and return. Yeah, you can do that, but I didn't do it. I just didn't want any further branching. Yeah. Yeah, you can also verify this by using Eclipse, using breakpoint debugger, and everything should be consistent, right? So that'll be the best way to understand what's going on. Any other questions? Okay, that's good. Yeah.
When the radius came 10, at point number 18, then to 19. Doesn't 19 happen first when, no, I mean, shouldn't 18 be at set radius?
Yes, 18 is about calling the set radius method. So that's why 19 will be when we step into that method, right? Okay? Yeah. All right, so let's now move on. Just one or two more examples about exceptions, okay? All right, the next one is about having 3 methods in the call chain, right? Just a little bit more complicated. Let's take a look at that one. So that one is really about the banks over here, okay? And let's now take a look at the methods that are actually involved. The entry point of execution will be bank application. And then we are having the main method. So this is where we started. And then we have the bank class, and we are calling the withdraw method from the bank. So So you can think about the bank here has the withdrawal method, right? So that's a callee. And within this withdrawal method here, we also try to call the withdrawal method from the account class. So that's something I'll speak a little bit more about, how you figure out the context class in just one moment. But withdrawal method here corresponds to the account dot withdraw. Right? So these are the three methods that are involved in this call chain. Right? Let me just write it down. And then we'll do some tracing together. So we start with the bank application dot main. That's the starting point. And then that one there is going to call bank dot withdraw. Bank dot withdraw. And then that one there is going to call account dot withdraw. Account dot withdraw. Right? So that's the call stack. And so there's a table here. You can feel free to fill in the three caller callee relationship. Right? I'll let you do that. All right. And then let's see what's going to happen at the runtime. Okay. You can see that over here in this withdrawal method here in the account class, this would be the origin of the exception if there's anything that's invalid to the input that happened. For example, we say that if the amount we want to withdraw happen to be less than 0, then we should really throw some exception. Or if the balance after withdrawing the amount will give you a negative balance, that's also not acceptable, right? You want to make sure you can only withdraw this much money that your account can afford. Let's give it a try. Let's say I'm trying to withdraw minus 5 million. That one should be disallowed, right? Let's see exactly how the program is going to reject that by throwing some exception, right? Let's take a look. Again, we're going to see the execution flow. So I'm going to try this particular input over here, right here, okay? So entry point of execution is here. So number 1. So think about 1, 2, and 3. So 1, 2, and 3 here are some programming pattern that we study in Lab 0. You're just creating some bank objects which will initialize the accounts array, and the first element there is going to be some account objects. And let's say we got ID 23, and also we got balance initially 0, right? So that's what we have done from the first 3 lines. And for those 3 lines, I'll leave you to study, right? That one is something we have done many times. And of course, number 4 is going to be we're going to ask the user to actually just initialize some scanner so we can read some input from the keyboard. And number 5 is where we're going to read the input from the user. So from this point here, user is going to enter minus 5 million, which should not be allowed, of course. And we're going to go to the try and catch block. Number 6, we reach the try block. Number 7, we are trying to make this method call. We're going to say bank.withdraw, basically, right? That one there. So this is the point where we got main method calls the withdraw method from the bank, right? Let's step into it. So we got this withdraw method here. So the next label should be number 8. So we're actually going to execute this for loop over here, number 8. Right? It really depends on how many accounts we have, right? Initialized to be 0, and then number of accounts is the counter that should be exactly just 1, right? We only got 1 account right here. So number 9, the first iteration. In the first iteration, I should be equal to 0, right? I'll just remind you here, I should be just equal to 0 when we get to number 9. So that means we got this particular line to be executed. Accounts at index 0, the ID should be equal to ID. What's the ID here, right? If you think about it. So this one here is 23, that's the ID. We want to withdraw from account with ID 23. So the ID here is 23. And we want to make sure we find the account with a matching ID 23. The current account we are looking at has the index 0, right, for the first iteration. So accounts at index 0, you can see that this account object has ID 23. So we are matching it for the very first iteration. And then we're going to do this line here to do further method call. All right? So number 10, we're going to do this method call. Okay? But for this method call here, I'll get to it. Let me write it down. And then I will talk about it in just one moment. So this one will be accounts I dot withdraw A. I'll get to it in just one moment. So number 10, what does that involve? Since we're making another method call in another class, let's step into it, right? So this will be the withdraw method from the account class. Okay, step into it. So now we're going to execute this withdraw method here. So the next count will be 11. 11 right here. Okay. The amount we have is 5 million, right? Remember 5 million, so this will be minus 5 million. And also the A here will be minus 5 million. And also the A here is also minus 5 million. So A here is definitely minus 5 million. If you look at just this part here, minus 5 million less than 0, true. And we have the OR operator, meaning that either this is true or this is true, we're going to throw the exception. We know that this is already true. We don't need to bother with this. Okay? It's true. So we're going to throw that exception. So we're going to go for, this will be number 12. We bypass the else part. So we're going to throw that exception. Okay? Throw that exception. So after we have thrown that exception, you can think about this part here is gone. And also this part here is also gone because there's nowhere to really handle it. And we go back to the main method here. So this is where we got suspended because of the method call. So we got two choices. Either we go to the next line or we go to the catch. We should go to the catch because we got some exception. So this will be where we should really go to. So this will be number 13, whereas the rest of the try block is bypassed. Make it a little bit bigger. Okay? So over here, so we got 13. And then we're going to execute every line in the catch block, which will be number 14. And number 14 will just print out the exception object itself. But if you run the code, you will see exactly what's going to be printed out in the Eclipse. For that one, I'll let you verify. All right, so that's the complete tracing for the execution flow. Because we try the input value that's negative, that's actually going to trigger the exception right here. You can try maybe another value there that's gonna maybe trigger maybe something different. I'll leave that experiment to you. Or maybe you can try to set a balance over here to be something big, so you can try some valid withdrawal, right? You can try a different scenario yourself. The final thing I want to talk about is this method call here. When you say accounts I withdraw, how do we analyze this line here? You will see this kind of line quite often, especially when you got array variable in your class, right? Apparently, we're using a dot notation, right? If you think about this part over here, it should be the context objects. And this one here is the method that we're calling. And this one here apparently is the argument, right? If you think about all the terminology that we spoke about in the review lecture. Let's now try to analyze this. We are making this method call right here in the context of the bank class. What's really the accounts itself? It's declared as accounts array, right? Right here, right? So I can now do some annotation here. Accounts is the accounts array. If I only look at the accounts itself, it has this type, account array. But right now, actually, I got an extra expression. Actually, it said index I. What does it mean? Get the account first and then go to index I. So the extended expression has a different type. If I look at this longer expression right here, right before the dot. Okay, if I look at just this part here, I got accounts, which is an account array at index I. That should really give me just the account itself, just a single account. It could be at index 0, could be at index 2, right? So this one here is going to be account. And now if you look at the context object here of type account, it makes sense to call withdraw because there's indeed a withdraw method in that class. Right? So that's kind of analysis you want to be able to do by yourself. Right? So what I just demonstrated to you, in order to figure out the exact caller-callee relationship over here, caller is pretty straightforward. It's bank and withdraw. We're calling this method here. What about callee? For callee, you got to figure out method name is pretty straightforward, just withdraw. But what about a class? It depends on the context object. And I just showed to you the context object here comes from the account class. Okay? That's why you got account.withdraw on the top when I figure out the caller-callee. I think later on in the course, we're going to see something maybe a little bit more, even more complicated than this. But let's start with this, just to begin with. All right, any questions? All right. If no, yeah, guys, study this example here. Even if you just understand about 60%, 70%, that's okay. Just catch up. And then let me know if you got any further questions. All right, I got 2 more examples. Why don't we go over them very quickly? Well, let's see. Right? Hopefully 5 minutes or so. And then we'll take a short break. Okay, 2 more examples. And the next example here is just about you may have multiple catch blocks associated with a single try block. The idea goes like this. In this try block over here, I'm calling 2 methods here. This method might throw certain exception. This method might throw another exception. So we got 2 possible exceptions that might be thrown from this particular try block. That is why you want to be able to handle both of them, let's say. So catch block number 1 and catch block number 2 is going to handle each one of them one by one. That's what you will typically do. All right, let's now take a look. So let's say this one here. If I say the withdraw method, and also I got a set radius method. So these are the 2 examples we just spoke about, right? About circle and also the bank. The withdraw method here may throw the invalid transaction exception, which will correspond to this particular, catch block. Meaning that if the execution flow goes such that at this line of method call, the invalid transaction exception occur, I'm going to be interrupted and go to this catch block right away, whereas I bypass the rest of the try block, right? On the other hand, this line over here is a different method call. And if you recall that one there may throw negative radius exception. And that one there corresponds to this one here. When you were doing like an individual exception that we kind of create on our own, like a negative radius and also invalid transaction, the order of the catch block doesn't really matter because these exceptions have nothing to do with each other. They just correspond to different errors that might occur at the runtime. Okay? Later on, we're going to talk about, once we get to inheritance, if time permits, we're going to talk about maybe revisit this example here. Sometimes, if we can somehow make the exception classes somehow related to each other using inheritance. But that will be too much for now. So for now, you can just assume that all the exceptions that we are trying to catch right here, they are simply customized. They have nothing to do with each other. So the catch block themselves, the order does not really matter. You can mix the order as you like. Okay? I'll write it down. So we assume the following. The customized exceptions. In this case, it would be, for example, the invalid transaction exception and also negative radius exception are not related to each other, are unrelated to each other. This means their catch block can be ordered in any way. So for our particular example over here, it would be okay if you simply cut this catch block over here and paste it after the green one. It's okay. That's my point. So that's the assumption we're making, at least for now. Later on, if I do have a chance to really talk about something a little bit more advanced, we can extend this example. But for now, you can assume that. Okay? Let's just do one tracing. And then the other one, I'll leave as example for you. So the first one here, let's say we are trying to do this one here. Okay? Let's say we are trying to trace this one together. Let's say we are going to pass maybe A here is going to be minus 5 million. And also the radius is actually going to be 23, let's say. Right? That's the input value we want to try. So what's going to be the execution flow? So you can think about R here is going to be 23, and also A here is going to be minus 5 million. Okay? Let's just set it right up front. 1, 2, 3. Okay, we reach the try block. Number 4, we create a bank, and then we add the account, and also we try to do some deposit. Okay, and then number 7 is where we try to call this withdrawal method, and we know that because the amount is actually minus, we know that it's going to trigger this invalid transaction exception, as we demonstrated earlier. So that means the rest of the try block is going to be bypassed, and we're going to reach some catch block. So now here's a tricky thing. Which catch block should we go to? Now this one here, because the exception that's being thrown does not match the negative radius exception. So not this one here. So conceptually, you can think about this part here is also bypassed. Instead, what we do is this invalid transaction exception is going to match right here. Right? And then once we go in there, we're going to say print out something and then print out something. So that will be the execution flow. Quick recap. For this particular A and R to be passed into the method call, it's going to trigger some exception right here. And the exception is invalid transaction exception. Number 1, we're going to bypass the rest of the method try block because some exception occur. And then which catch block should we really go into depends on what exception is being thrown. Because invalid transaction exception is being thrown, so this catch block has no effects. It will just be bypassed. And this one here, invalid transaction exception, is matching this one being thrown. So that's why we'll get there and then execute each line. Okay? Conceptually, you can also think about outside the try and catch block, there might be some more code, right, to finish off your program. So you can think about this could be 11. So you can think about this part here is outside the try and catch block. Okay? Any questions about this? Yes? You have to throw the exception in the following sense. For example, let's say the withdrawal method. So if you recall that example there, if you look at the withdrawal, you can see this is the account class where the withdrawal method says if the amount is actually less than 0, then we'll throw this exception. Assuming that you're developing all these 3 classes, yes, you have to write this line to say I throw this exception. Right? Exactly how that exception will be put into the stack, removed from the stack, it will be handled by Java at the runtime. Yeah. Yeah, you go first. Yeah.
So let's say we have these 2 cache blocks, right? So for example, let's say we put another third cache block with that exception keyword, the universal one, just to catch.
Yeah.
Right?
Good. Your fellow student was asking, what if I say I try to catch rather than some customized exception, I simply put exception over here, which is a class in Java. Guys, for now, you don't need to worry. Because in order to understand exactly how this works, we need to understand about inheritance hierarchy, which I don't want to touch upon. We will have lots of discussion on inheritance. If we do have time left for the semester, I can briefly talk about this. Talking about it right now is going to cause further confusion, which I don't want to. Okay? You can assume that unless I explicitly talk about how this can be handled about exception in the catch block, it's not going to appear on your test. Okay? I think this is good enough for now. Yeah, you can just assume that the catch block will simply correspond to what exception might be thrown from different method call in the try block. and then just enumerate all of them in different order you like. Yeah?
The previous slide, so the class for the invalid transaction extends.
Yep.
I believe you showed us, just want to confirm, you showed us
how to create this exception. Yeah, so yeah, maybe for that one, I wouldn't maybe say too much because you can just go back to the part of the recording maybe from last, I believe, Tuesday. So as soon as you type out, throw certain exception there, Eclipse will give you an option to create that class for you. Maybe just go with that part of the recording, you'll see, okay? You're gonna need that for sure for lab number 2, a lot, okay? Okay, guys, one more example, okay? But just before we do that, let me just... All right, so the last example I want to talk about exception is a very interesting use about a try and catch block and execution flow. And let me present a problem to you first of all, so everybody knows what the problem we are solving. And then I'll show you the solution, which does not take that many lines to write. Okay, right here. Let's make the following assumption. Well, actually, that's a known fact. In Java API, so there is a class called integer. So you guys can feel free to Google for the integer class in Java API. Just go to see this method here. In the integer class, so there is a static method. The method being static means we don't need to create an integer object to call that method. We can simply say integer, capital I, dot, parseInt, right? So this method here may throw number format exception. So now we try to apply what you learned so far. So now this method here basically says it may or may not throw number format exception. Meaning that when you call this method here, you have to handle it somehow. Either try, either catch or specify. Let me say that again. Since this method here may throw this particular exception, if you are the caller of this method here, you got two choices, either catch or specify. Right? I'm going to show to you how we can use this kind of requirement here to do some interesting application. Okay, so here's a problem that we want to solve. So let's say, just an example here, if you say integer that parseInt, and the argument is going to be some string. If I simply pass to you 23, which can be turned into an integer, so it's just going to return integer 23. So we actually transform from string 23 into integer 23 right here. On the other hand, if I give you, let's say, 23 here instead as the input to parseInt, that one cannot be turned into integer 23. So that one there is going to give you number format exception, right? So calling this method here, depending on what you pass to it, you may or may not throw that number format exception, right? That's kind of the context, okay? Pretty much like, when you want to set a radius, if the radius is negative, you throw the exception. If that's not negative, it doesn't throw the exception, right? So similar. And this is what we want to, you can write it conceptually in your mind. I'm going to show you the solution. We want to have a fragment of Java code that's going to prompt the user to enter to you some string, which could be either 23 or can be 23 right here. And your program is somehow going to be tolerating enough. If they enter something that cannot be turned into a number, you're going to give them some error message and prompt it again. Otherwise, if they finally give you something that can be turned into an integer, you're going to turn that into the integer. All right? This may sound familiar to the version number 2 of circle calculator that we spoke about today. Right? So this one here uses the Boolean variable in a similar way. Okay? Excuse me. Yeah, so that's a program we want to write. I'm going to present to you the solution right away just to save some time. But I would suggest maybe after today, you can also think about this page over here and try to write out the program yourself. That's also going to help understanding the exception. Okay, let's now go there right away. Right, so that's the code that you have to write. Right here. All right, so let's now highlight the Boolean variable which we studied earlier today. We got this Boolean variable, and also we check it to decide if we want to go for another iteration. And also we may set it to be true, And also we may actually want to, let me see if there's anything else. Okay, that's it. Okay, so these are the three places that we try to use the Boolean variable the same way as we did it for the circle calculator too. Let's now try to trace that right away. Let's say we want the user, first of all, to enter from the keyboard something. They give us 23, which cannot be turned into an integer. And then we're going to prompt them again. And the second time, they're going to enter 23, which can be turned into 23. Right? Let's now give it a try. So we're going to go start from the beginning. So let's say number 1, create a scanner. And then we're going to set this variable here to be false. Right? I'm not going to visualize that anymore because you got it, from earlier example. So this will be false. And then we're going to check the while loop condition here. Not false is going to be true. So go for the first iteration. Number 4 over here, we're going to tell the user, enter an integer. Enter an integer. And let's say the user enters 23. Okay, so they are simply just going to enter 23. Okay, imagine that they will respond by entering 23. And then this will be 5, and then number 6 will be reaching the try block. And then we're just going to go to line number 7, which is very critical. Now, for the very first time, we are actually going to call this method here with the input 23, right? So this will be the first time, right here. So that one there, the user input is 23. Since this is a Java API method, we cannot really go into it. But based on the description that we had earlier, over here, remember we said it might throw number format exception. We already defined under what circumstances it can throw. So in this case, it will throw. So now in this particular case, it's going to throw number format exception, because 23 here cannot be turned into a number. Okay? Now, what would be number 8 then? Where should be number 8? Should this be catch, right? Exactly. Similar logic, right? Okay, number 8 should be the catch, right? Catching number format exception, right? And then number 9, we're going to let the user do it again. You can say 23 invalid, right? It's not a valid integer, something like that. Notice that the value for this Boolean variable here remains to be false. So when we go back to the while loop, right? So now when we go back to the while loop, number 10, we are actually going to say not false, which will still be true, right? So now this time for this new iteration, we're going to enter 23. Okay, let's see. So 10 and then 11, enter an integer. All right, so that will be number 12. Number 13 for the try block. Number 14, we are calling this method for the second time, right here. But this time, the user enters 23. That means this will be the number that's being entered, right? The user will simply enter 23 right here. And we know that this one here is not going to throw. Number format exception not thrown. Meaning that we should really go to the next line, right? 15. This one here is going to change the valid integer to be true, whereas the catch block is going to be bypassed. What's going to be number 16? Where? While loop, because we haven't really exited from the loop just yet. So number 16, I'll put it here, is going to be the while loop. So now we're going to check to see not valid integer. Remember, it's being set to be true. Not true is going to be false. So exit from the loop, And then we're just going to be around here. So number 17. Exit from the loop. All right, so this is another just interesting application, but the principle is really the same. You're calling a method which may or may not throw some exception. You might either go for the rest of the try block, or you might go directly to catch block. You're going to use this kind of pattern here. We're going to see that again in the next new lecture when we talk about JUnit testing. Guys, any question? All right, so I think now we are officially done with the exception lecture here. We have gone over many examples there. You're now more than ready to really do lab number 2. Lab number 2 in some ways is cumulative. You have to somehow review the patterns that you did for lab 0, lab 1, and also the new bit will be about exceptions. Okay, I'm pretty sure it's going to be very rewarding if you can struggle enough before the submission deadline. And I got another tutorial video for you after the submission deadline, which will go over with you the solution again. But I would say before you look at the video, before submission deadline, try to do as much as you can. That'll be the best way. This Friday, myself and the TAs will be there and then help you with lab number 2. Or if you want to talk about lab 1, that's fine too. Why don't we take a very short break by taking attendance, and then we'll start a new lecture. Okay, we got about 20 minutes after the break. All right, so now we are done with the exceptions lecture. I want to just go to the slides and tell you something very quickly. So in the very beginning of the lectures, we actually talk about how you can use the consoles to actually do error messages. So these slides are very self-contained. Take a look just to compare and contrast. When you have exception versus you have no exceptions, what's going to be the difference? Okay, so those slides you can go over on your own. Okay, for that one there, I'll leave to you. And then if you go to the end of the lecture here, so these are just some suggestions about some exercise that you can do. Okay, so we made available source code, and also you should really use a breakpoint debugger to see the normal versus abnormal execution path. I think that's one of the most important learning outcomes from this lecture. Right, the code is there. Take them. Feel free to extend it or modify it as you wish. So that's about the exception. Okay, so what I will do is I'm just going to start a new lecture. Okay, and I'll just open that very quickly. There we go. All right, so the next new lecture will be about JUnit testing and also test-driven developments. I'll talk about it. We can only do a little bit of intro and maybe some small example today, I think the most. But we'll see how much we can go. All right, so this is something called test-driven developments with JUnits, which you guys have been doing really since day one. You were given maybe some empty model package to start with, and then you are basically given all the JUnit test cases to you. And then you kind of use that to drive your development. That's really test-driven developments. You have been doing it just without knowing that's exactly what you're doing. It's a very sound self-engineering practice, which we'll keep doing, for all the labs and also for all your programming tests. But I just want to dive a little bit more into it. Now that we learned about exceptions, exception turned out to be a very useful way to really structure your tests, to really test for both a normal scenario versus abnormal scenario. Like a normal execution flow versus abnormal execution flow. That's something we'll definitely dive into. These kind of stuff might seem a little bit tricky at first, but once we kind of analyze the logic there, they're not too bad, right? That'll be the main focus on Thursday. But for today, I want to do a little bit introduction and some review. Okay. All right, let's see what we're going to cover. There's one diagram I want to also bring to your attention. If you go to the lecture site, you will see that here we already got the lecture slides. Oh, by the way, the Lab 1 solution walkthrough video is right here. Right? I kind of mentioned that in the E-class. Right? You can find it there. And then, so this diagram here is really a workflow diagram that summarizes about test-driven developments. It's more like an iterative process, which means it should never end as long as your project doesn't end. You should always try to practice test-driven developments for as long as your project may last. That's something I will also go over in detail, possibly not today, but maybe on Thursday. I will explain to you how exactly this can be understood. Okay, we'll get there. But the diagram is there. You can store that somewhere or print it out if you like. Okay, let's now go over some slides and now go back to the iPad. Oh, let's see this one here. So we're going to see how we can do the testing of some simple counter. So this will be some running example we're going to do. Right? I'll introduce the example at least for today. Right? How the example should be understood. And also we're going to derive the test cases for the bounded variable. There are certain lower bound and upper bound for the counter. So we want to know if the counter value is within the bound, how should we test it? If the counter somehow goes out of the bound, either too small or too large, what should we do? Right? Things like that. And then we're going to see execution flow. That's really the stuff that we learned from the exception lecture, but now we're going to apply that to the TDD, test-driven development context. And then we'll talk about when you write a test, it may be either testing where exception might be expected. It might be testing where exception is not expected. I'll get to it in a little bit more detail. Okay? Test-driven development and something called regression testing. I will talk about regression also maybe on Thursday when I get to the diagram. All right, so these are the learning outcomes we want to achieve by this lecture. But let's now introduce that counter problem. Let's just get yourself familiar with the problem first. All right, let me just start from the beginning here. First of all, let's review very quickly about the catch was specified principle, right? So if you recall, so whenever you want to specify, you basically say the throws keyword, right? Either this is the place where the exception is originated, so that's the origin of the exception, which we typically just do specify. Versus if you're calling a method that might throw some exception. The caller can choose to specify. This may throw some exception. In this case, the caller may also choose to do specify. So here is really the caller may choose to specify. So there are two scenarios. Either it's the method of the exception origin, or it's the method where we call some method which may or may not throw that exception. Right? Just to specify. And the catch, basically, if you see the try and catch block, that's the catch option. Right? If you look at that, so we got a try and catch right here. Try and catch. The reason that we had to use a try and catch is because, first of all, you can see the main method here. There is no throws, right? First of all, no throws. That means no specify. Option chosen. Instead, if you look at this method here, C2.M2, we say that this may throw some exception. That's our assumption. May throw some exception. Because you're calling a method that may throw some exception, you're subject to the catch with specified requirements. In this case, we choose to catch, right? So this is the point where any further caller will not be subject to the catch with specified requirements anymore. If you imagine the call stat that we spoke about earlier, right? The summary, when I do the recap, think about that way. Okay. Right, very quick review about catch with specify. And then let's now talk about the counter very quickly. Okay, for the counter, we have a classical counter right here. Of course, we're going to create counter objects at the runtime. And let's assume the maximum value for the counter will be 3. And the minimum value for the counter will be 0. Lower bound should be 0. And upper bound should be 3, inclusive. Okay? So there are 4 possible values for the counter, right? If you do the math. 0, 1, 2, 3. Only 4 possibilities. Just make it simple. And then we got some integer attribute here, just the value. And we got a constructor. And we assume that when we first create the counter, we just assign that to its minimum value 0. Okay? And then we can easily get the value just by returning the attribute, right? Very simple, right? So for this lecture here, we're going to have some very simple example in the model, but we want to see how we can understand the testing of this counter, okay? And we also assume there are two possible exceptions, okay? There are only two methods we have. Either you can try to increment the counter by incrementing by 1, and also, or you may decrement the counter by decreasing its value, either way. However, when you try to increment, you got to be very cautious, because if the current value of your counter has already reached its maximum, you should not try to increment any further, right? So in that case, if the counter value is already 3, but you still try to increment, in that way, we choose to specify right here. Well, this is the origin of the exception, actually. So we may throw value too large exception, right? So this is the specify option, right? Value too large exception. Symmetrically, you may also choose to decrement the value, but now it has to do with lower bound. If the current value for the counter reaches its minimum, meaning 0, you should not really try to decrement it to -1. You shouldn't. In which case, we will throw some value too small exception. And we also choose to specify it in this origin of exception. Any questions so far? Should be pretty straightforward Java code to look at, right? Okay. So we got a counter class, and we got some lower bound. Sorry, we got some lower bound, we got some upper bound. And increment may throw some exception if we are already at the upper bound. And decrement might throw some exception if we are already in the lower bound, right? Logically. That's the Java code. I got about 8 minutes, so let me just go a little bit further, just try to show to you how we can derive some test cases very quickly. And we'll use this derivation strategy on Thursday, okay? Let's see how much we can do. Should be good. Okay. So this is the so-called state diagram. And in the state diagram, you basically say each state is going to be a combination of all the variables you're interested. Okay? Each state is characterized by the values of variables of interest. You don't necessarily have to include all the attributes of your class to really include the state diagram. You only need to include those that are interested. But in our case, we are just interested in the counter's value, right? And as we said, the lower bound is 0, upper bound is 3. So you also got possibility 1 and 2, right? You got 0, 1, 2, 3. The state diagram goes like this. This arrow here tells you that I'm going to first create the counter objects, okay? And I know that as soon as I create a counter object, by default, it's going to be lower bound value. So this arrow here tells me that. So we have some initial creation of the counter objects. And think about the 0 over here is really the minimum value that we define, right? Minimum. And on the other hand, we also got 3 being the maximum. And if you remember, we also got 2 possible methods that might modify the value of counter. We might either try to increment or decrement, right? Either way. Let's see how these increment decrement can be turned into our diagram. Think about each state is like for the object, we can make some method call. For example, C here is the object. So I can either say C dot increments or I can say C dot decrements. For each state, I can do that. I can also try to say C dot increment over here when the counter value is 1, and also C dot decrements when the counter value is 1. I can do. All right? So let's see how we can make sense out of this. Here, if I do C dot increment, what's going to happen? It should go from 0 to 1, right? So for that one, I'm just going to put an arrow here. It's called transition. So this will be a single increment. And if the current value is 1, I can do another increment if I wish. That's going to go the value from 1 to 2. If the current value is 2, I can do another increment, which is going to increment it from 2 to 3 right here. And then, if I'm now in this maximum value already, I can do decrement, for example, right? So I can say from 3, I can say C dot decrements, so it's going to decrement from 3 to 2, right? Decrements. So here, I really meant to say increments here. And then here, I can do another decrement that will go decrement from 2 to 1, and decrement again from 1 to 0. I deliberately leave out 2 options here. Did you notice that? For example, what's going to happen if I try to do decrements when value is 0? And what's going to happen if I try to increment when the value is 3? So these are the exceptional scenarios, right? So let's give it a try. So here, if I try to increment again, what I should expect will be value too large exception. Value too large exception expected. On the other hand, if I am already 0 here and I try to decrement, I should really expect value too small exception. Are we okay so far? You can think about the arrows over here correspond to how many scenarios you should really test for your counter. You should really have one test which will make the counter value 0 and then try to increment and see if the corresponding value is actually 1. Also, you should also try to start with this setup as well by trying to decrement instead, in which case you want to somehow make sure this value to small exception is also thrown. That's something we're going to see. Okay? Let me say the following. We can somehow categorize all these scenarios into 2. Scenario number 1. Let's say for all the increment and decrements, all these. For all the increment and decrements right here. Okay, let me just use a different color here. Okay, sorry. Let me just do it again. Okay, for all the increment and decrement right here, so these are the normal scenarios that we want to test. Okay, I'll say number 1 here. Okay, number 1 will be the normal scenarios to test. On the other hand, if you look at this one here, and also this one right here, these 2. Okay, I'll call that number 2. Number 2 here. So number 2 will be the abnormal. Scenarios to test. Okay, just give me 1 more minute and then I'll let you go. Okay, for number 1, if you think about it, for number 1 over here, if I'm testing all these, do I expect any exception to occur? I don't, right? For number 1 here, if the exception occur, that means I should fail the test. If the exception not occurred, then I may have to pass the test. I'll elaborate this a little bit more, but I want you to see the difference, right? For number 1, I don't expect any exception to occur right here. And for number 2, it's going to be completely the flip. Okay, let me finish this part, okay? And here, if I say the exception occur, either value too small or value too large. Occur, you're going to pass. Let me say expected exception. Expected exception. Either this value too large or value too small, either one. Okay? That should be passed. If the expected exception did not occur, that one you're going to fail. Right? So we're going to elaborate on this in much greater detail on Thursday. Right? Thank you so much, and then I'll see you on Thursday.